Hey guys, so let's discuss today binary search tree. So what is binary search tree? See, it will have one rule, and that rule will be its left child will be lesser than its root data, and right child will be greater than its root data. So for example, if I have a subtree something like this, 200, 100, okay, or 250, then this one will be lesser, and this rule applies for each node of the tree. Okay, so this one will be 50, this one will be 150, this one will be 220, this one will be 300, something like this. So if you check here, left is 50, root is 100, and right is 150. So it means that left is lesser than root, which is lesser than right. This condition will be there, then it is a binary search tree. Okay, okay, now we need to perform some operations here, and I will cover all the operations in one video only, and those operation will be insert, okay, delete, and seal, floor, and search. Very easy. Okay, very easy. So let's check first search, insert. Okay, insert. So the structure of the tree will be same as another node, like data left and right. Okay, and if you wanted to insert some element, you just need to first find it's a perfect place to insert. So for example, I wanted to insert 350. So 350, first I will check whether it will exist in a left subtree or right subtree. Okay, so for example, see, if it is greater than root ka data, then I will definitely go to right hand side, right subtree. If it is lesser than root ka data, so I will go to left subtree. Okay, so 350. So first I'll check the root data. So 350 is greater than root ka data, so I'll go to this right hand side. Now again 250, 350 is greater, so again I'll go to right hand side of 250. So 300, which is greater. Okay, so again I'll go to right hand side of 300, but 300 ka right is null. So what I will do, I'll add my 350 here, right side of it. Okay, because it is greater. So this is how you do the insert. Okay, you dry run it. This is the recursive version of it. Okay, if root equal to null, so return new node key. So that is what we did. So here this was the root and it came to null, so we just created new node here and assign it. Okay, if key is less than root ka data, so go to left hand side, root dot left equal to this function, or root dot right equal to function. Let me dry run it for you, at least one. Okay, at least the insert I can dry run. So let's say I wanted to insert 350. Okay, so this function will run, insert function will run for what? Root and key. So root is 200 and key is 350. I want to insert 350, right? So I'll go here. Now root equal to null, no. Key is less than root ka data, no. So I'll go to else part. Okay, so what it is, key is greater than root ka data, yes, correct. This is my root and this is my key. So key is greater than root ka data. Okay, so what I will do, root ke right mein I will call insert root ka right. So root is 200, so this one will be 250 comma 350. Okay, now whatever is happening here, we will come back on that, but first check what will be the value of this insert 250 comma 350. So here again this condition will run, key is greater than root ka data. Okay, so this one will run root ka right is equal to insert of what? 250 ka right, so 300 comma 350. Again this function will run for insert 300 comma 350. Okay, so root ka right is equal to, because 350 is greater than 300, is greater than insert, what is root ka right is null comma 350. So when this insert null comma 350 run, okay, it will check that root equal to null, yes. So it will create new node key. Okay, it will create one node 350, and then so this new node 350 you will get here, and where it will assign root ke right mein. So what was the root? 300. So 300 ke right mein you will assign 350. So this is how it will work. Okay, now let's check another function, which is search. This is very simple. Now you people think about it. If you wanted to search let's say 150, so first you will check with the root data. Okay, if it is lesser than, then you will go to left subtree, and if it is greater than, you will go to right subtree. Okay, this thing I will not dry run, just check just see the code. If root equal to null, then return false, you don't have that data. Okay, you reached till the end, but you haven't found the data, means you don't have that element in the binary search tree. Otherwise, root equal to data, root ka data equal to key, so return true. If key is less than root ka data, so go and search in left subtree, root ka left comma key, otherwise right. Okay, now seal. What is seal? So seal is your value, okay, which is greater than or equal to key. So let's say if I'm asking you what is the seal value of 251. So I need to find that element in the data in the binary search tree which is greater than 250 or equal to 250. If it is 250, then fine. Otherwise, I want greater than value of 250, and that too, just next greater. For example, if here it is 350, okay, so I don't want 350, I want 300, just next greater. Okay, so how you will do that? Very simple. So what in Ceil function you will do? You will initially Ceil will be null. If root is not equal to null, okay, then if root is not equal to null, so you will check root ka data equal to key. If yes, then root ka data you will return. Okay, if it is equal, then so very good. Okay, we don't need to search here and there. Otherwise, if key is greater than root ka data, so go to root ka right. Okay, if key is less than root ka data, so you first assign root ka data into Ceil, because that could be your Ceil value. Okay, or root equal to root ka left. Okay, why the question is why you are assigning this root ka data Ceil value in this else condition and not in this if condition? So when you dry run it, you will come to know that, see, till here what you wanted to find 251. Okay, so I know that my element will be greater than or equal to 251, but never the less than. Okay, so I will check with 200. So 200 is saying no, I am lesser. Okay, so go to right. So 250 you will come. 250 will also say I am lesser, go to right. So 350, you found this is the first element which is greater than 251. So this could be your answer, right? So that's why in this else condition, where first time your root data became the smaller than the element, that time you will assign this. Okay, same thing for the floor as well. So floor is your value which is lesser than or equal to key. Okay, so here everything will be same, it's just the here you will use less than and you will use floor equal to root data, here you will assign here, and at the end you will return floor, or at the end you will return Ceil. Okay, that is also done. Now delete is remaining. So delete is very simple. Okay, people think that it is very tough. No, very simple. You just see what is happening, what needs to be done. Okay, that's it. So for example, let me take one example here. Okay, and we will check their three conditions. Okay, so let's say I have some value like 200, 150, 250, 350, 450. Okay, this is 375. This one will be 225. This one will be 50. This one will be 170. This one will be 180. Okay, correct. This is satisfying all the condition of binary search tree. Now I wanted to delete node from it. Okay, so we will see three examples. One, delete the node which has no left and right. Okay, so let's delete 255. Okay, no child condition. Now I want one element which has only one child, so 170, delete 170. Okay, one child. And I want to delete the node which has all two child present, so 350 or 250 I'll say. Okay, 250, two child. So let's see how you can delete it. See, very simple. Only this much code is there for the delete. Okay, what you do, let's take the example of 225. Okay, so your function will run delete. Okay, delete function will run for root. Root is 200. Okay, and what you need to delete 225. Okay, fine. So what you do, see, if definitely this is the normal condition that if key is less than root ka data, go to left side, otherwise go to right side. So here we will go, my 225 is greater than 200, right? So I'll go to right hand side. So here root ka right is equal to, okay, again I'll run this delete function with root ka right. So root ka right is 250 and 225 I wanted to delete. Okay, then I'll run this function for 250 comma 225. Okay, my data 225 is lesser than the root ka data, so I'll run this root ka left. Okay, now here left will come, root ka left equal to delete, and what it would be now root ka left 250 ka left, so 225 comma 225. Okay, both are equal, we don't need to check for equal. Okay, again this function will run delete 225 comma 225. So here key is not lesser than root node, key is not greater than root node. So see, this condition will not run, this else condition will also not run. So now you will come to the main condition, which is this else part. Okay, now here you will check whether your whether your key means this 225. Okay, not 225, whether your root, okay, this is root, so whether your root has one child, two child, or no child. Okay, so this is your one child, this is your no child condition. Root ka left is null, root ka right is null. Yeah, my root ka left is null, root ka right is null. So in that case, what you will do, just return null. Return null means where you will return null. You will return null in this here. This function will return you null. It means root ka left to become null. What was root? Root was 250. So 250 left will become null. So when you change its reference, it means you have deleted the element, right? So this one will become null. So you deleted it. That's it, right? And let's take another example. Okay, let's take another example, and that example will be of what was here, 225. Okay, now let's take another example of when the root has one node, okay, one child. So in that case, what will happen? This one is done. Okay, this one is done. Now it's time for 170. So 170, I wanted to delete this one. Okay, so I'll call this delete function for 200 comma 170. Now my key is less than root ka data, so this one will run for root ka left equal to delete function, it will call for 150 comma 170. Okay, now delete function, it will call 150 comma 170. Okay, and here my key is greater than my root element, so root ka right. Okay, here you just check this whether we are assigning that value in right or left. Okay, it depends on your key value whether it is lesser than or greater than root ka node. So it will run for delete. Okay, 150 ka right, 150 ka right is 170, 170 comma 170. So here again, when you run this delete 170 comma 170, okay, here it is not lesser than, not greater than, so this condition not run, this condition not run. Now here you will check whether both it has no child. No, 170 has one child, which is right. Okay, so this one will not run, this one will also not run, and this one will run. So right, root ka right equal to null. Yes, no, root ka left is equal to 1. Okay, this is condition true, so root ka right it will return. So it will return root ka right, root was 170, root ka right was 180. Okay, it will return this 180, where it will return, where this function gets called. So 180 will get returned here, and here what is this? Root ka right, and what was root? 150. So 150 is right, I will assign 180. 150 is right, I will assign 180. Okay, so it means I have deleted that 170, correct? So then this one 180 will come here. Okay, root ka right equal to 180, and then what is next? So you return that value, 180 came here, root ka right became 180. Now you have two 180, 180, 180. What you will do with two 180? You have to remove one, right? So it means that from here again you consider it as one tree and run this function once again here. So what you will do here, you will find the two condition return root. Root ka right came here, no? No, you have deleted 170, right? Root ka right is 180. Yeah, that's it. So now next question you take where, so 170 is also done, right? Now 250, you take example of 250. So what will happen in 250? Let's see. Okay, in 250, now you need to delete 250. So you will run this function delete 200 comma 250. Okay, you will run this function root ka right, okay, equal to delete 250 comma 250. So this 250, delete 250 comma 250, what it will do, it will again 250 comma 250, which is not root ka left, not root ka right. So what you will do from here, you will return so this no child condition false, because in this 250 you have both the child, 225 and 350, you have both the child, right? So in that case one child is not also, this is not true, this is not true. Now this one will run. So you will find the minimum value from right subtree. Okay, see, if you know, if it is a BST and if you run this BST into in order, okay, so you will get the sorted values of the tree, right, in ascending order. So for example, if you wanted to delete 250, you need it's a what it is called, successor, in order successor. Okay, predecessor is this value and in successor is this one. So let's say if it is 251, so you require 251 so that you can replace this 250 with this 251, okay, and not any other node. Otherwise, if you randomly take any node and replace it here, so this will not be valid as a BST. Okay, no more valid as a BST. So we need to respect the condition also at each node. Okay, fine. So I will find the minimum value from root ka right. Either you take the predecessor or you take the successor. Okay, so if you wanted to take the predecessor, so you will go to left hand side and maximum value of left hand side. If you want successor, so minimum value of right hand side. So if you check here, we are checking for 250. Okay, 250. So it's a right hand side. What is the minimum value? Minimum value is this one should be 325. Okay, so 325, let's say the minimum value is let's say it's a 325. Okay, so what I will do, so my successor will become 325, and I will put this value into root ka data. My root ka data, root is 250. Okay, so instead of 250 I'll put 325. Okay, 325 I have replaced it here, 325. Okay, now what else? So now you run this function again, root ka right. Okay, so my root was 250, so 250 ka right means 350. So again I will run this function, root ka right is equal to delete of what, 350. And now what will be my root data? So root data will be successor data, this is 325. I need to arrange that link also, right? That's why I'm calling this one again. Now let me remove this one here from here, and this one from here as well. Okay, I need to run this delete 350 comma 325. So where I need to find 355, and my root node is 350, so I'll go to left hand side. So root ka left equal to delete, okay, 325 comma 325, because 350's left is 325. Okay, so I'll go to 350 comma 325 comma 325. Okay, root ka left. Now here if I go and check 325, so I'll check I don't have any nodes here for 325, right? Any left or right child? No, nothing I have. So I will just return null. Where I will return null? Root ka left. So root was 350, so 350 ka left will become now null. See, this is how I have arrange this node. So here the null will come. So now can you see the tree BST 200 325? Okay, 225 is lesser than 325, 350 is greater than 325. Okay, 350 null and 450. So this is correct, right? And you deleted that node also to 250. Okay, so and this is the main method of it. Okay, so that's it. Thank you.